All right. How's everyone going? How's everyone doing today? Good. Last session of the day. All right, let's get started. So my name is Nathan Totten. I'm a technical evangelist at Microsoft. I work on Windows Azure. I focus on web scenarios and social gaming scenarios on Azure. And today we're going to talk about building social games for Windows 8 with Windows Azure. So to begin, basically this talk is for anyone who's interested in HTML5 games, Windows Azure, game development, or building games for Windows 8. So hopefully that's you. We're going to talk about some of the architecture of games. We're going to talk about some scenarios like storing data for gaming using Windows Azure storage solutions. We're going to talk about some of the communication scenarios around gaming, how we handle scale, and we're going to also talk about how we build and connect a Windows 8 game to Windows Azure. So hopefully at the end of this talk, you will have an understanding of cloud-based casual game architectures and sort of how to build a game on to meet your needs using Windows Azure. So a little context about this talk and sort of what we're going to focus on. This talk is about a little more than just Windows 8, right? We're going to talk about building a game for the cloud. We're going to talk about building games for devices around a rich ecosystem, right? We've got a variety of different devices we can build in. We're going to talk about building services that work not only with Windows 8 games, but also mobile, iOS, all kinds of other games, web games, etc. So, and then, the idea is basically you would build the game targeted to your device, high-resolution graphics, really nice experience for a bigger device, a more powerful device like Windows 8, and then a scaled-down version, maybe less features, maybe lower-resolution graphics for things like mobile. So some of the features we're going to talk about are, and sort of that are common with these connected cloud games, right, are authentication, user settings, storing the game state, the real-time communication, and then the game services like the leaderboard, achievements, things like that. So those sort of features are going to be kind of touched on throughout the talk, and we're going to focus on the architecture, but this is sort of the idea of what type of features we're going to be talking about, we're going to be building to. So as I mentioned earlier, right, there's a big ecosystem of devices now. It's not just one, it's not just the iOS social game. It's not just a web game. It's not just a Windows 8 game, right? You as a developer, as a company who wants to make games, you want to target all the experiences probably. You don't just want to build a Windows 8 game because, people want to play on their phones also. So that means, you got to build for Windows Phone, iOS, Android. But maybe you also want to enable people to play in their browser. So there's, the HTML5 browser-based game. So there's a big ecosystem out there. And part of what we're going to, the focus of this talk, again, is building services, building on Windows Azure to enable rich quality gaming applications, or building those types of games across those devices. So to begin, I want to show a quick demo of a game you actually saw earlier in the week. It's called Tankster. The game was featured briefly in the Day 2 keynote by Jason Zander. This game is I'm going to demo the HTML5 version, but we do have other versions of it. So this is going to set the context. This game is part of something we'll talk about a little later called the Windows Azure Toolkit for Social Games. All the source code is available for this. So we're just going to go through a little quick demo to sort of set the stage about what we're going to talk about later. So I'm going to switch over to my machine here, and we're going to play a multiplayer game. I have an audience assistant who's going to be the second player. And actually, if anyone else has their laptop, anyone have their laptops out want to play? You have like 30 seconds, and you can also join. So, this game, we're connected to Windows Azure. This is an HTML5 game built, functions across browsers. We're running it in IE. It works on any browser that supports modern HTML5, Canvas, things like that. So we have one opponent. And we're going to wait a little bit for the thing to start. So again, this game is running on Windows Azure. It's an HTML5 game. The gameplay is actually using the Canvas, so it'll work in modern browsers, IE 9, 10, Chrome, and some of the, I can't remember which version of Firefox they're on anymore. And as soon as this starts, hopefully, we have a demo. Oh, there we go. Okay. So I'm going to pick some weapons here, and we're going to wait the awkward 30 seconds to choose the weapons. So again, we're cloud connected. So right now what's happening is our game state is stored in Windows Azure. My assistant Wade is also choosing his weapons. So we're both going to be choosing our weapons. It's communicating with Windows Azure. And in a few seconds, our game's going to start, and basically the state of that game is going to be stored in Windows Azure so that both players can receive that state and generate the sand, put the tanks in the right place, have the right weapons for each player stored on Windows Azure. And Wade gave me a little decal there. Thank you. So shoot the game, or shoot my weapon. And now what happened there is, and we'll go into more detail on this later, but I fired that weapon, and we're connected through WebSockets. So my command and the information, the velocity, the weapon I use, the power, was actually sent through the cloud to Windows Azure, and then sent via WebSockets to Wade's browser. And he, on his screen, saw that exact same thing happen, and he apparently has already won. So that was a pretty quick demo. He's gotten very skilled at this while we've been building this game. So great. Yeah. So through the cloud in one turn, Wade has defeated me. So all right. So let's switch back to the slides. I was going to fire a few more shots, but I guess you're just too good. Where's my little clicker? So that was Tankster, again, a cloud-connected HTML5 game. Like I mentioned, there are several versions of this game. We will right now the source is available in our toolkit for the HTML5 game, and that's the only one that's actually published. But we have actually built 3 different versions of this game. A Windows 8 Metro style game, and that was actually the version that was demoed on Wednesday, yesterday in the keynote, and the Windows Phone version, and that was also seen in the keynote. They all function basically the same way. They're built on the various technologies appropriate to their platform, but they all have that cloud backend in common. They all connect to Windows Azure. They all use the same backend service APIs, and so the idea of that is, the beauty of that is we can move a lot of the game logic, a lot of the various services like the leaderboard and stuff to the cloud so that it's easier for us to build those client-specific implementations. So to start, I'm going to run through the architecture of this game, sort of how this game works. We're going to go through the common flow actually that we just saw of starting a game, inviting another player. Actually, we're going to show a little more than we just went through for the demo. The scenario we're going to show is starting a game, inviting a mobile player to play that game, that mobile player accepting the invitation, and then the invitor, the Windows 8 version of the game, is going to accept the invitation or start the game, and then they're going to go through the gameplay. So I'm going to walk step by step sort of through what is happening in the cloud and how those services are working to enable that connection between the devices. And then afterwards we'll go into sort of why we did that and some of the choices we made and some of the benefits, and also some of the benefits and disadvantages to using one way or another, and sort of your options for that. So to start a game, what's going to happen here in this scenario is my Windows 8 version of the Tankster is going to click the Start a Game button. Then we're going to send a command to our Windows Azure web role services. These services are they're regular REST JSON services written with the WCF web APIs. So send a command to the game, and then that application is going to immediately begin pulling Windows Azure blob storage, and I'll sort of explain that in a second. So after that, that game is now continually pulling Windows Azure blob storage. Our web role, those game services, then queues up that start game command in Windows Azure queues. The worker role is reading from that queue, reads that message from the Windows Azure queue, processes the command, which is start game, basically generates that game, and then stores the game state in Windows Azure blob storage. Now, the beauty of Windows Azure blob storage is 2 things. One, it's extremely scalable. You don't have to worry about how many connections really within reason, is going to hit Windows Azure Blob Storage. The second thing is it's a service, right? So you don't have to worry about configuring it. The third thing that's really nice about Windows Azure Blob Storage is it's publicly accessible. So we can actually have our HTML client or our phone client hit Blob Storage directly. The advantage of this, rather than going through the web role, is sort of, there's a few things, but mainly it's scale, right? Rather than having 1,000 web roles handling my 10 million clients, Tankster is that popular. No? Okay. So rather than having a whole bunch of web roles handling all that scale, having our clients hit the web roles directly, what we do is we actually offload a lot of the storage of state, things like that, to Blob Storage so that we don't have to worry about managing the scale. So again, now where we're at is our game is hitting Blob Storage, and it's actually waiting for the worker role to update the game container, which contains the state of the game. So the next thing the next thing is that player on the Windows 8 version of Tankster is going to invite their friend on the phone. They send that invite out. Again, it hits the web services on our web role. Same thing, queues up a message. The worker role reads that, adds that invite to the state of the game. The other thing that happens is we have information on our users, right? We know where our users are. Are they, we know what kind of client they're on. Are they on a phone? Are they on the web? Are they on the Windows 8 version? And since we know that information, we can figure out what is the best way to contact that user. If they're on the web, if they're connected, maybe we can push out a notification to them via sockets. If they're not, there's nothing really we can do. We can maybe send them an email. But if they're on something richer, like a phone or a Windows 8 application, we could actually send them a push notification. So the worker role would know which user was invited, again, know what type of device they're using. And in this case, we're on a phone, so what we would do is send a push notification to that user using Windows or Microsoft push notification services. Once that phone user receives that invite, then they're going to accept the game, or accept the game invitation. So that phone user, once they accept that invitation, is going to call the REST services again and do what the Windows 8 version is, continually pulling Blob Storage, waiting for the game's state to be updated. That acceptance is going to do the same thing, go to our queue, worker role is going to pick it up, and add the message to the game state, which says, okay, now there are actually 2 players playing this game. And because the Windows 8 version of that game is actually hitting Blob Storage, it's going to know, okay, they've accepted the invite, you're actually now ready to start the game. Excuse me. So the Windows 8 player of the game, I should have named these. I now regret this. I have to say Windows 8 or Windows Phone. Okay, so player 1 on the top on Windows 8 is going to click Begin the Game, hit the game service again, same thing, go through the queue, worker role, and now the worker role is updating that game container, telling all the players of the game, okay, the game is started. So now those players are going to want to connect to something a little more robust, right? When we're playing a game, we don't want to rely on blob polling for several reasons. The biggest of which is the time delay, right? If we're polling blob every 2 seconds, that's fine when you're just talking about sending an invite out, right? If we're just waiting around for a bunch of players to start the game, every couple seconds is fine. But if we're actually playing the game, especially, Tankster maybe it would be okay, but especially if you're talking about like a game with lots of users that has lots of actions going on at once, like polling the blob for the turns of the game is slow. So after the users are alerted sort of that the game is started, they're going to connect up to our socket server. The phone version is just going to connect with regular sockets. The Windows 8 version could connect with either web sockets or regular sockets. And if we were on a web version, if that browser supported web sockets, we would connect up with web sockets. Otherwise, we could scale down to some other technology like long polling. But basically, they're going to connect up to our socket server. So, okay. So the first person who's going to shoot that game is going to be the Windows 8 going to be the Windows 8 player. when they send the command to, say, shoot their weapon, that same information, that information required to execute that command on all the clients of the game is going to be sent to the socket server and instantly pushed to the phone. So when you saw in that demo one, when I fired a shot, it instantly played on Wade's machine. He saw that exact same shot. When he saw a shot and killed me in one turn, we saw that animation on our screen. So that's happening through a socket server. It makes it a very rich, very fast gameplay. However, there's also some other stuff we want to do in the background. So we're again using that same pattern of command query. So that same game command is sent to our queues, read by our worker role, and one example of something that it could do is add it to the game state in blob storage. But this is where, from building a rich game environment, this is really where the magic is going to happen, right? Because there's a lot of things we need to do to really build a great game. We need to, track what the user does to give them achievements. We want to keep stats to build our leaderboard, so we want to keep track of things like how many successful shots do they have, how many people they killed, all these types of things that are really going to take our game to the next level. So this is where we queue that stuff up, we read that information, and then in our worker role, in the background, without affecting our user's gameplay, we can actually do those calculations. But again, the key to that is we aren't doing that real time in the game because it would slow everything down. We don't want our users to have to wait while we say, oh, did you earn another achievement, right? So what is it? Sorry, apparently I have this twice. Okay, so that was a mistake. Okay, so the patterns we saw there for building this scalable, disconnected, robust game, we're using something you saw over and over, that command query separation, where we send a command to the game server, in-queue a message, and read it from the blob. The one thing you'll notice about one of the big things you would have noticed from all of those steps is we were never doing a read from the web role. We were only reading from blob storage or receiving information from sockets. Again, this gives us a lot more scale, separates things out, makes our system a little more robust. We rely heavily on queues and blobs for storage. These are regular REST services, so again, we can connect a lot of different devices, and we're using sockets and web sockets, depending on what sort of socket technology the client has. So that's how our game works. Now, the next thing I want to talk about is how we scale our game. So building it on top of Windows Azure gives us this really rich, really great platform that enables scale. But you still have to sort of you can't just throw it up there and just hope it works, right? So how do we build our application to enable really high scenarios, right? We all hope that we're going to build the next Angry Birds or Tankster. I have a greatly inflated impression of how many people play Tankster. Have you all played? No, okay. Probably not. We want to build a game that has a lot of scale, right? So again, we're building it on Windows Azure. We want to build decoupled systems. We want to be able to scale parts of our game. We're not just shoving everything into a web role and putting it all on IS, having these services that do all these calculations synchronously. We want to disconnect everything so that we can enable scale, so we can scale each part of the system. The biggest way we're doing that is with this command query separation pattern. So again, the way this works is we're going to send that command to the web server. The web server is going to enqueue a command, and the worker role is going to read the message and do something with that, whether it be update the blob, save something to SQL, whatever. This is the biggest way we're going to enable scale because, again, we don't have to have a whole bunch of web roles. We rely on lots of different things like blob storage to actually enable that scale. So again, an architectural diagram of this is something we already saw. Send the message to the services, pull blob storage, add a message to the queue, read from the queue, and update blob storage. So that's our pattern of command query. So that's how we scale the game. The other thing to note is Okay, sorry. Okay, yeah. So the other thing to note is, again, we talked about these services we're building, these command services. These are regular REST services, so they're available to any type of client. We could use them from on an iPhone. We could use them on Windows. We could use them on in the browser. So this is just an example, real quick, of what of how we call that service. This is our JavaScript implementation of calling the start game service. And then this is the start game command. This is on the web role where we receive this command. So the thing to note about this here from a scale standpoint is this web service is extremely simple, right? This is the only thing this command or this web service on our web server is doing is adding the message, which in this case is game command, to a Windows Azure queue. That's it. It doesn't, again, it doesn't call SQL. It doesn't calculate anything. It doesn't really return anything besides an OK. So this is a very fast command. This will keep our clients, responding very quickly and keep the load on our server from decreasing. And actually, there's a really easy way now that there's now that there's .NET 4.5 with the async. You could actually make this even faster by enabling by making these commands asynchronous, and that would, really bump up the scale on your web server. It would be very performant. And then the real work of this is actually happening on the web role. So this is our process commands. Really not, very simple illustration of how that works. We're constantly reading from our queue, and then we're pulling that message down, and then we're calling our game service .do something. And, we don't know what it is, but that last call, game service .do something, is where the work is really happening. But again, this is on our worker role, disconnected from our user, so we don't have to make our users wait while we do our calculations or build our leaderboard, anything like that. So this gives us a huge amount of scale and really keeps our system in separate pieces where we can control the scale in a very fine way. If we're getting a lot of traffic, we probably only have to increase our. Actually, a perfect example of this is with Tankster. We actually bumped up our web roles. Because with build we anticipated there would be a lot more people playing it. We wanted to make sure that it was going to be responsive. So we actually bumped up our web roles to, I think it was 10 instances. But our command, our worker roles, really they're stuff's happening in the background. If things get delayed a little bit, it's not really a big deal. So we actually left our worker roles at 2 instances, which is where they always are. So again, the nice thing is, rather than having all that stuff happening on one set of servers, we separate it out so that we can control scale in a more finely tuned way, which from a standpoint of cost decreases our cost. We don't have to pay for servers that we may or may not be using. So we talked about the 2 different types of ways we're going to send data back and forth to the clients. For simplicity, I'm going to call one push and one pull. So push communication is our sockets, right? It's real time. Actually, so let me go back. Sorry. So there's one thing. There's one thing to note with this game. With the architectural diagram I showed you, we're using sockets for communication. We actually, in the game toolkit and while building this game, we actually have 2 different ways we could have done that. In the game right now, we're using sockets for communication to speed up the gameplay. But in earlier versions of the game, we actually used blob polling for everything, for the game commands, for the chat, for all those things. So what it did is it actually caused maybe a 1-second delay when the shots were fired or when a chat message was received. And for us, for Tankster, we wanted to speed it up. We felt the experience was a little bit better, so we moved to sockets for that communication. The thing to note, though, is for some types of games, you may not need that socket connection. Think about a chess game. If you're playing chess, it probably doesn't matter that the commands take, say, 2 seconds or even 5 seconds to get from, player A on his Windows phone to player B in his web browser, right? That may be something that works very well for your type of game. It just depends on the type of game you're playing. So these 2 strategies are somewhat interchangeable. You can choose the one that works best for you. And so we'll talk a little bit about I'm going to talk about the advantages and the disadvantages of each strategy. So the push communication strategy is more real time, right? We're using sockets. A command gets sent from one player, and appears almost instantly on the other player. However, the disadvantage of this is it requires more compute instances, right? I need to actually put those I need to put those in web roles or worker roles. So the more people connected, the more of those I'm going to need. This is more cost-effective for fast-paced games. If you're making a game like Tankster, you want the shots to appear really quickly, this is going to be more cost-effective for you. And I'll explain a little bit more on that in a second. So the push technology, WebSockets we've mentioned, you could use something like SignalR. Another disadvantage with the technology, though, is that there's somewhat limited compatibility on browsers specifically, right? So if you're using WebSockets, like IE9 doesn't support WebSockets, so if you're using something like SignalR, it's going to actually revert back to long polling, which is fine, but not ideal. So the push communication architecture we saw, push a message to our socket server, pretty simple, sends it to our other device. Now poll communication, as I said, is the other strategy. There's a slight delay in game commands depending on your poll frequency. However, it's less compute intensive. We're using blob storage for that, as we saw earlier. We're using blob storage for that. We don't have to worry about the scale of blob storage, right? Azure does that Windows Azure does that for us. We maintain the scale of the blob, of your blob storage. Just hit it basically as much as you want. Don't worry about it. Pay for what you used. However, depending on the amount of time, the poll frequency, things can get very expensive. With Windows Azure Storage, you're paying for transactions. It's pretty inexpensive. It's like 1 cent per. It's 1 cent per 10,000 transactions, which is pretty inexpensive. But imagine if you want to simulate real-time communication with blob storage. You basically have to poll 5 times a second, right, to simulate that real-time communication. If you have a lot of people playing that game, that can get very expensive. This solution is generally more cost-effective for slower-paced games. I would say, like if I were building a chess game, I wouldn't put a socket server in there. I would just use blob polling because your users aren't going to know the difference, and it's most likely going to be more cost-effective for you. The technology we use for this poll is blob storage, just HTTP requests. It's compatible with every single device that can make a connection to the internet. Architecture is quite basic. So, I'd mentioned earlier what's the trade-off, and basically the trade-off is speed versus scale. With blob storage, you're going to get more scale, but it's probably going to be slower. With sockets, you're going to get less scale in the sense that you have to make, you have to make more, build more, have more instances of your servers, but it's going to be faster. Now, as far as which one do you use, that's actually not some. I don't have like if you need to make it happen this fast, use blob storage, or this fast, use sockets. But there is a trade. There is a function where you can basically figure out, okay, if I'm polling enough, and you can look at, for your game, what you would do is analyze the cost, like how fast do I need things to happen, how many users I'm going to have, and at some point, I would say start with blob storage, start with the poll. And at some point, if you figure out, okay, I'm going to have a lot of users and I need to have a lot of communication, I'm going to be polling the blob a lot, at some point you're going to see that, okay, your storage transaction costs are actually going to become higher than what it would cost for you to run, say, 10 instances of in Windows Azure with sockets on it. So again, there's not a magic number where I can say use this in this case and use this in this case. But for you have the option, and I think you can figure out which one suits you best. So now I want to talk about Windows 8. Right, this is the Windows 8 part of the talk. So to set this up. With Tankster, we actually started about 3 months ago, and we built an HTML5 version of Tankster. It works in IE9 or above, Chrome, Firefox, regular HTML5. We use jQuery, all the normal things you would expect in an HTML5 game. And then, then we decided, okay, it would be really cool if we had a Metro-style version of this game. So we didn't want to start over, right? We wanted to reuse the code we've already written. So what we did is we actually we took our HTML5 version of the game, and we basically created a Windows Metro project, and we figured out, okay, what are the things we need to change to make this game work in Windows and give a great, part of it wasn't not just making it work, but also giving a great Windows 8 Metro experience. So let's switch over to my computer here, and then I'm going to talk about what we had to do to change that and sort of what the end result was. Hang on, my password has timed out. There we go. It would have been really bad if I'd have forgot my password up here, right? Okay. So this here is our, use my little zoom thing, okay. So this is our first version of Tankster. This is the version we built for the web. We built this, it's a Windows Azure service, or Windows Azure project. We're using ASP.NET MVC3. We built it, using the regular MVC stuff. We built it using Razor, and oops. Hang on, let me get out of this. And so we've got our views. We actually only used one view. It has a ton of HTML in it, which actually in the end simplified our process of migration. But we have our views. We've got our regular stuff. Content, we've got our CSS files, we've got all our images, all the regular things of a website. Obviously, we don't need to go into huge detail about that. But okay, so how did we move this over to Windows 8? So this is our Metro project. Looks very similar. We have a default HTML page, which is nearly identical, or actually is. Yeah, besides the Razor stuff at the top, is identical to our web version. And we have our CSS, our fonts, our images, our JavaScript files, all the regular stuff. The thing you should notice on this, though, is almost every file in here is a linked file. I only actually had to change, I believe, 4 files in this project to make this work on Windows 8 for a Metro app. So we used jQuery, we used all that stuff. Part of what I had to change is there's like one issue with jQuery that there's like a security thing. We didn't use some tracking software, so I just made a stub for that. And then the only other real thing that I did is I added another JavaScript file to my Metro app that sets up our application and also does some stuff that's only available in Windows 8, like that bottom bar and some responding to some gestures, things like that. So as far as what our process was for converting, it basically was create a project, link to all our files. We changed a few file paths, copied some of the HTML over. We made a new CSS document, right? Because the web version, if you actually, from looking back from earlier, the web version, it runs in this little frame. The reason we do that is because basically we found that most browsers don't really perform that well if we have like the whole page. We couldn't really get the performance we wanted by building a full screen canvas game across all the browsers. Like it actually works really well in IE because of the hardware acceleration, but in some of the other browsers it actually would sometimes get pretty slow when we try to do it in full screen. So we actually scaled the game down in our HTML version to a smaller size so you can only see parts of the game and you can actually scroll, you can scroll back and forth. Well, for a Windows 8 app, we didn't have that problem, so we decided, okay, we want to actually enable the full Metro experience. So what we did is we built, all it actually took was some JavaScript modification. We changed a little bit of HTML, and we built a new style sheet. And the result of, okay, this is there we go. No, okay, it's supposed to be opening. It does work. There we go. Okay. So the result was that we were able to reuse a lot of our assets. We were to connect to the same services in Azure, the same socket server, and we were able to build a better game experience because we were able to do that full screen mode. And I'm clearly having some issues here, but we got some demo ghosts or whatever. So it does load eventually. You saw it on Friday, or on Wednesday, sorry. I can't remember what day it is. So yeah, once it maybe loads eventually, you would see a beautiful full screen version of Tankster, in theory. And the bottom bar. So, all right. Let me kill this. Hang on. We'll give it one more try, and we'll just then you can just take my word on it. But you did see it, and actually, some people didn't realize that the version they saw on Wednesday was actually a Metro version and not just a browser and full screen. But the version we were showing in the keynote was actually this Metro version, the full screen immersive experience. There we go. All right. Let me just start a local game in this one. And I'm going to do this, oops, we've got our, I'm going to do this single player so Wade doesn't beat me. But here what you see is that we actually have, okay, minus those bars on the side, we actually haven't, I forgot to change the resolution. There's a bug we didn't fix with the bars on the side. It was a CSS issue we actually haven't had time to fix. But there is canvas extending all the way throughout the game. So what you see here is with very little updates to our game, we were able to take our HTML5 version and make this really cool touch, immersive Metro, Windows 8 Metro style game, I guess. And we added, I didn't add a lot. There's a ton more features we could add that are, specific to Windows 8. But we added some, we actually took, in the HTML5 game on the top, we had like the About button and some of the sound buttons. And I took those and I moved those to the bottom bar. We could do a ton of other stuff like integrating with the sharing and all that. But the moral of the story is it was extremely easy for us, if that's the wrong version, to port this game over to Windows 8 with our existing assets. So, okay, yeah. So let's switch back to the slides. Okay, so. I'd mentioned a little bit about this earlier. So we have a lot of things we talked about, right? All these services, the sockets, these architectural patterns. How do we use those, right? So one thing we've made available, and it's actually already available to download, and we'll be updating into the future. We have what we call the Windows Azure Toolkit for social games. So in here, we've packaged up actually the entire source code for that Tankster game that's running in the browser, all the back-end Windows Azure services, all the web services, all the images, the sound, everything are actually available in that toolkit. So the toolkit actually enables you to take some of the lessons we've learned, use some of the architectural guidance, and use that in your application. So the toolkit has a lot of the common features that you would expect and want in your game. Weapons, gifts, achievements, all these things. The real-time communication with the sockets or the polling that we showed to actually enable you to build your own game on Windows 8, on Windows Phone, etc. And again, I mentioned this earlier, these APIs are generic. They're REST APIs. Nothing is specifically tied to a particular platform, whether it be Windows 8 or Windows Phone. You could use this toolkit. You can use the server APIs to build a game across all the platforms, Windows Phone, iOS, Android, HTML5, Windows or Mac. So that's basically where we finished a little bit early. Okay. So that's basically as far as the talk goes. The toolkit's available as Windows Azure Toolkit for Social Games.codeplex.com, and there's also some stuff on my blog. So what we saw here, right, is we saw the Tankster game. We learned how to how we took that game from HTML5 and moved it over to Windows 8 with ease. We use the same back-end services. We talked about the patterns of cloud-connected games, using sockets, using the command query separation, how to do the data storage, how to handle scale, and how to do real-time communication. So with that, I am actually finished. So we have plenty of time. We're actually 10 minutes earlier than I thought, so we actually have double the time I had planned for questions. So if anyone has any questions, feel free. And also, please go up to the microphone, otherwise I will get yelled at. Not literally, but they like to record your questions.
So the first thing is, would you mind going back like 2 or 3 slides to where you had what is included in the toolkit?
Yes.
It had a nice little chart there. And then one of the things, okay, so that's a great slide. The toolkits included things like GIFs and achievements and things of that nature. Are you talking graphic assets, or are you talking the logic behind how you would accomplish that in code? Also, the type of casual games that this toolkit enables. Is it more like the Tankster model, where it's 2 people, 3 people playing in a more rather real-time environment? Will it allow you to build the chess-style game? Will it allow you to build a Farmville-style game? Will it allow you to build, if you've seen Travian, which started in Germany, it's very popular, and that's ultimately what I'm getting at, what I would like to do. Thank you.
Yeah. So the first part, as far as what's included in the toolkit, we actually include the full source of Tankster. So the Windows Azure projects, the whole web server APIs, the HTML5 source, the JavaScript files, the images, the sounds, everything. So, like, those are particular for the Tankster game. So they're not necessarily I mean, you could reuse them if you want, but they're not like, there aren't, I suppose, like generic images and whatnot that you would use to build any game, but you're free to use anything you like in there. So the full source of the game is available. The server APIs are completely independent of so there's there's server APIs that are completely independent to Tankster. There's actually several APIs that are tied directly to some specific functionality in Tankster, but for the most part, the server APIs are completely generic, would enable a variety of gaming scenarios. So, as far as the second part of what type of scenarios does this enable, I think there's 2 things. Really, being as generic as it is, I think that this is a starting point for probably most any type of game. I mean, when we were building this, our goal was really to support a variety of different games. Like we looked at the Farmvilles and the turn-based games and all these things, and we sort of looked at the patterns and sort of the features that were needed to make all these types of games. So I'm not going to say you can build any game you ever imagined with it, but I think it would give you a really good start to any of those types of games you mentioned. And actually, so one thing to point out, we don't included in the source yet is actually only the Tankster demo, the Tankster sample, but we are actually going to be adding tic-tac-toe sample, which is not quite as complicated as Tankster in the future, so that you can it's a little easier to understand how it works, but also it shows like how you would build the chess type of game rather than the sort of real-time type of game. We don't have that in there yet, but we will get it shipped in there soon. And then as far as reusable assets, there's like 55 JavaScript files. They're all the files are tied to Tankster. But like most of them are extremely generic. We use several libraries. We use Easel.js, which is a library that's available for download, which was made by Grant Skinner, who is actually the designer of this game. There's a whole ton of assets that are available that you should be able to craft and mold to your exact needs. So does that answer that one?
Yeah.
Okay. Yeah, so we are just as far as like our future plans. Right now, it only includes Tankster. We are going to try to make it a little easier because Tankster is pretty complicated. That's why we started to build out these tic-tac-toe type scenarios to make it easier for you to actually digest what's in there. Like if you just wanted to use one part of the toolkit, we don't have any of that stuff up for release, but we are working to get that there. very soon to make it easier to say, like, if you just wanted to make a chess game where you could pick it up and begin right away without having to dive into every single feature of Tankster. So go ahead.
Does your server enable UDP or other connectionless sorts of server push mechanisms for massive multiplayer stuff?
It does not yet. No, we haven't done anything with that. It'd be an interesting feature, but no, unfortunately. Yes.
Did you give any thought to using Azure Service Bus for the two-way communication, so you don't have to, from what I understand, whether through queue or topics, it can shoot information both directions?
Yes. So actually, we did look into it. The reason we didn't use it in our current versions is actually because it wasn't, it was in CTP. So we didn't want to build on top of CTP technology. However, Windows Azure Service Bus offers some really, really nice features that could definitely integrate into the game. The one particular scenario that I've actually thought a lot about integrating is actually, I mean, you could do the front end stuff also, but I actually think the best solution, the best place that I can think of where Windows Azure Service Bus will be used and where we'll probably use it is on the back end with say something like achievements, right? So with Windows Azure Service Bus, you now have you have topics you could subscribe to. So what you could actually do is push every action of a game into a Service Bus queue and then actually pull out different pieces that you need that are relevant to like you say you have a worker role that's job is to just or some function in the worker role whose job is to calculate who earns achievements. You could pull out just a subset of the messages that are in the queue and then perform a calculation on them. So I think actually that from what I've been thinking about, that's actually probably where we're going to put the Service Bus in there because it is something. There's a lot of cool scenarios for it. But that'll be our first one probably. Mm-hmm.
When we're talking, if you're really successful, the number of requests is going to be a manufacturing expenses. So, how do you decide on which of these to pull?
Yep.
You don't know ahead of time what the costs will be.
Okay, so I'll repeat that just so everyone here. So the question was follow up on the sort of push-pull model, right? How do you know which one to use in terms of cost? There's, with the push using sockets, you're going to need web roles, worker roles, whatever, to actually run your sockets. And then there's, at some point, there's X number of clients that can connect to a particular server. With blob storage, it's really scalable. I mean, there are some limitations of blob storage that are really high, but basically you can scale blob storage up and only pay for what you're using. So in terms of cost of that, I mean, I don't have exact numbers. Like there isn't anything I can say. Like again, if you need to pull this many times per second and have this many users, it's cheaper to go one route or another. One of the reasons, like you said, is that there's various beta technologies or whatever. But and there's too many variables to it. But I will say this: in our testing, we actually put together some like equations, and we try to do some formal way of actually determining which one would be cheaper. And for the most part, I would say if you're building a game that doesn't require, like say you're polling every 2 seconds, I think that's going to probably be, from what we've done in our testing, like with Tankster, polling every 2 seconds is going to be cheaper than running WebSockets with any reasonable number of clients. If you only have a few clients, you could you could share your socket server with your web server, and then that's probably the very absolute cheapest way to go. But with any reasonable number of clients, I think if you're talking about a slower paced game, blob storage is probably less expensive, and also you get the benefit of not having to manage a second set. You don't have to worry about a web role and increasing this. You just dump it onto blob storage and it works. If you're doing the fast-paced games, if you use blob storage, you're going to have to pull like in a millisecond, say 5 times a second or something at the slowest to simulate real-time communication or interaction. If you do that, I mean, if you look, I mean, you can do the math, but if you're on like if you have 10,000 clients, do it polling 5 times a second. That's 5 cents a second. Which adds up. That actually is fine. That wouldn't be that much a month, but I guess it would be that much a month, yeah, wouldn't it? So yeah, depending on your budget, if you're Zynga, 5 cents a second is like probably nothing. But if you're just some little, if you're building a small game, then it probably is a lot. But I would say, again, the guidance basically is, in my opinion, I guess, and in our testing is, fast-paced games probably go with sockets. Slower-paced games use the polling. So, yeah. Anyone else? General Azure questions. We have
I've got a couple questions for you.
Oh, sorry, I did not see.
One relating to the blob storage that you were just talking about.
Yep.
Does that support e-tags so that if I already have the blob and I request it, is there a lightweight way to tell me?
Yes.
Okay.
So e-tags are supported through the CDN. Do you know a way to do e-tags exist on the blob also? They do. Okay. So yes, they are, and you can do the same thing with if you wanted to do use the CDN, the Windows Azure CDN or blob storage. Yes, e-tags are supported.
Okay, because that would make that polling scenario, it seem like, a little cheaper.
Yes. Yeah. You certainly there would be ways you could make it
literally cheaper if it's charged per minute.
Yeah. I think so. I'm not actually. Does that? I don't know if that still counts as a request as a transaction though. I don't know. I'd have to look into that.
Okay.
But yeah, I know you're not going to.
I don't know the economics of it, but I'm thinking if the number of bits sent back are smaller, it should eventually be cheaper.
It certainly would be cheaper in terms of bandwidth, but I would think that probably still counts as a storage transaction, but I'd have to follow up. But it would certainly save you money in bandwidth, which wasn't in my equation, which certainly would be a factor, when doing enough requests. So.
Okay, so my other question is about the socket server that you were talking about. Mm-hmm. So I guess that code is included with everything that you're packaging up?
It isn't yet, no.
Oh, okay.
Yeah. Right now, the version that's packaged up only supports sockets. At some point, we'll want to get WebSockets in there, but a bunch of stuff needs to come together in terms of support on Azure and things like that before we can ship that. So I actually don't know when we'll be able to ship that, but hopefully soonish.
Okay. Well, that was sort of the second part of my question was if you guys, so you're not doing WebSockets in the version?
We have WebSockets working, just that we aren't shipping the toolkit with WebSockets yet.
Okay.
For various supported scenario, what's supported on it. Like for the toolkits, I don't want to ship code that's not supported because then it's like you don't want to use it anyway. So
can I assume that it uses .NET 4.5 framework in IIS 8?
No.
The new WebSocket support that was announced this week?
No, it actually doesn't
Okay.
because Server 2008 isn't in Azure. We're actually using a somewhat custom solution,
okay.
Which is part of why we don't want to ship it because it's not like if you became Angry Birds and stuff, you probably I don't know if you would want to use what I did, So IIS WebSockets is certainly going to be a lot better than that. So yeah.
Okay, and last question is the push notification services stuff that you talked about. I'm not real familiar with that, but does it talk to say iOS push notification?
Yeah. So actually, in the game, what we're using is we have another toolkit. We have several other toolkits. One is called the Windows Azure Toolkit for Devices, and the other is called the Windows Azure Toolkit for Windows 8. Both of those toolkits are what we are using. We're using the code in those to enable push notifications. So you can actually go download both of those toolkits also, which have notification support for Windows Phone, iOS, and Windows 8.
Okay, great.
Yep.
Thanks.
So that code is all available. Cool. Anyone else? 5 minutes. Azure general questions. Windows Azure general questions. Personal questions, not too personal. No. Someone's hand went up when I go ahead. Hopefully it's not actually a personal question.
So use just Azure Storage as opposed to Azure SQL. And I realize in this scenario, you were just sticking stuff in blobs. Like, what kind of stuff were you sticking in the blob? You're going to look speed and weapon type and things of that nature. Were they all like in a JSON format? Did you ever give any thought to put them in a more relational table format for SQL Azure? I mean, what influenced your decision?
So to clarify, we actually do use SQL Azure for some of the stuff. And in particular, the leaderboard uses SQL Azure. But basically, our choices had to do with scale, and also there's two things. One is scale, and two is blob storage can be connected directly with the client. So, if we put something in SQL, we have to proxy that through. We're obviously not going to give our storage credentials directly to the guy running our phone app. So we proxy that through a web role. So in terms of scale, if we were using SQL Azure for all of the stuff, we would need more web servers to handle that scale. Our goal when building this was actually to build this toolkit to handle like scale of a reasonably successful game. We sort of built this in the way that, okay, what if we do get really big? Like, we didn't think there was any value of building this, and it only really works if you have 10 users. Like, we wanted to be able to handle the scenarios where you actually did get successful and have lots of games. So the blob storage helps us scale a little better in a lot of solutions. But SQL Azure is great for those relational type situations, and the leaderboard, because we don't need to make a request to the leaderboard every turn or whatever, the leaderboard is great SQL Azure is great for the leaderboard because it enables us to do the things we would want to do with the leaderboard: sort, filter, query based on, okay, I want to find where I am, in the ranking. Perfect scenario for SQL Azure. So that's really we chose the tool that's right for the job, or at least in our opinion. So. Oh, yes. So the question was what file format? What did we put in the blob? So what we're actually doing, and we also use tables. Do we use table storage? No. They help. They build it. So no, we don't use table storage at all. So yeah, I forget. So for the blob, yes, we're storing JSON objects, and actually, what we actually are storing JSON P objects, so they're wrapped in like a function, so that we can call them cross-domain from any web browser without the cross-domain issues and having to use some proxy like Silverlight or Flash or whatever. So they're JSON P objects, JSON code stored in the blob. Anyone else? No? Yes? Oh, sorry, the lights I can't see over there. Go ahead.
In the architecture you used with your worker pattern, you used MSMQ or SQL queues. When does that become a bottleneck in this architecture, and what to do when that happens?
Mm-hmm. Yeah, so to clarify, we used Windows Azure storage queues to do that, and that becomes a bottleneck. Currently, queues are limited to 500 transactions a second. So it becomes a bottleneck at 500 transactions a second. There are a few, and this is actually on our list of things to figure out guidance around. There are a few different solutions for, 500 transactions a second is good. I mean, if you're probably if you think you're firing a weapon every 5 seconds, 10 seconds, you can get a lot of people on there. But at some point you're going to reach that limit if you get big enough. And so we're looking at various solutions for that. The easiest solution, and most likely what we'll put in there, is some sort of scaling out solution where there doesn't really matter how many queues we have. So we could actually have just randomly select queue 0 through 5 and just insert a message and have worker role, one worker role reading 0 or 0, 1, whatever. So we would split it out where we could get above that 500 requests per second. So yes.
I'm really new to the cloud. I didn't even realize when I was looking up in the sky that that's what all those things really were. But and I'm serious, I am new to the cloud. My question is, I believe Azure is attempting to be, a broad solution that can go across iOS and Android, et cetera. However, I suspect that it still favors Windows running devices. And my question is this: are there other cloud solutions like Azure that are PaaS type solutions that game guys are using today? And can you kind of compare and contrast at an extremely high level that?
Yeah, absolutely. So yeah, there are certainly other competitors out there. So there's two parts to that question, I think. One is, what other options are out there? How do we compare? The other is Windows Azure only for building, is Windows Azure only good for building games that are consumed by Windows clients? Let me do the second one first. So as far as preference of client connection, I would say that definitely is not the case. Like you could build a server on Windows Azure today using like a whole variety of technologies. You could build like ours is .NET servers. We use WCF web APIs, but those APIs in no way care what type of client connects to them. You could connect with, it's JSON. It's just a regular HTTP request, so you can connect with any device that can make an HTTP request. iOS, Android, all the Windows devices, anything. So I would say it's definitely not the case that Windows Azure is only good if you're using Windows clients. I mean, you could actually not have any Windows clients and still use Windows Azure. There's absolutely no reason you couldn't do that. You could build, so again, we built our services in WCF web APIs, .NET, C#, but if you wanted to, you could build your services in PHP or Java or any other, anything that runs on Windows, basically, you could run on your server. So, your services are sort of irrelevant to your client. The other part of that is the other part of the question was, what other cloud solutions are out there? So there's certainly a lot of them. I won't list them. But how do we compare? So we generally think of the cloud in two different buckets, right? One is what we call platform as a service. The other is what we call infrastructure as a service. So Windows Azure falls into that platform as a service bucket, where the idea is we give you a bunch of services like blob storage, like like service bus, like access control services, and we compute worker roles, whatever. Where you basically, the idea is you build your code. You deploy it to Windows Azure. You don't need to think about, you don't even care that it runs Windows. You build your code, you deploy it, and it runs. Like you don't care about the firewall, you don't care about the load balancing, you don't care about managing SQL, you just use SQL, you just use blob storage. So that's the platform as a service idea. The other bucket of cloud providers, I would say, are this infrastructure as a service, where they give you a place where you can host something. Like if you want, XYZ technology, put it on a VM, set it up, configure it, run it in the cloud, and they'll run it, and you pay them for the time to run it. But so the big difference is sort of the level of what you have to do. With Windows Azure, write your code, consume your data, it just runs. With sort of the infrastructure idea, you're responsible for making sure your web server is configured correctly, your operating system's running, et cetera. They're both running in the cloud, but the level of what you have to maintain, I think, is different. And so that's really where we see our differentiation. All right. No one else? All right. Well, thank you very much, and I'll be around if you have any other questions, and thank you for attending.